this movie, we answer this question about a momentum collision calculation, and we use it as an opportunity to revise some important concepts about momentum, change in momentum, impulse, and force. Make sure you watch to the end when I summarize these relationships more generically to help you to apply these to other questions too. Download the question from the link below and try it yourself first. Did you know that you can find many resources to help you learn natural and physical science topics on my website, www.learnscience.coza. Also, don't forget to subscribe to my YouTube channel. In this question, we first have two balls moving towards one another. They collide. After the collision, we know that one of the balls now moves in the opposite direction to before, but we're not told how the other ball moves, and that's what we've got to find out. We're going to use the law of conservation of linear momentum to find this out. That states that in a closed system, the total momentum of the system remains constant. So the total momentum of these two balls before the collision, momentum initial, equals the total momentum of these two balls after the collision, momentum final. In questions like this, it's very important to include direction because momentum is a vector quantity. Since this is linear motion, we can represent the two possible directions with signs, plus and minus. So we start by specifying what we mean by these. Let's choose east to be positive. It doesn't matter which direction we choose to be positive. As long as we apply that consistently, we'll get the same answer. So now, let's substitute the values we have into our equation, being careful to pay attention to the signs for direction. We've decided that east should be positive. So this one's moving towards the east, so that's positive 10 meters per second. This one's to the west, negative 15 meters per second. To the west, negative 5 meters per second. We're trying to find this value out. We know that momentum of the whole system initially is equal to the momentum of the whole system. Finally, let's write that in formulae. The sum of the initial momenta, P is the symbol for momentum, is equal to the sum of P final. mv of P initial plus mv of Q initial is equal to mv of P final plus mv of Q final. So now we substitute the information that we have. We have to be very careful of signs here. 0,16 multiplied by plus 10 meters per second plus 0,2 kilograms times minus 15 meters per second is equal to 0,16 kilograms times minus 5 meters per second plus 0,2 kilograms multiplied by the unknown value, which is the velocity of Q final, and that is what we're trying to solve for. So now, of course, we must be very careful with our algebra, especially with the signs. We can see that this is obviously 1,6 positive plus 0,2 times minus 15 is minus 3,0 is equal to 0.16 times minus 5 is equal to minus 0,8 plus 0,2 VQ final. So you see, we need to get this one to that side. In other words, add 0,8 to both sides. Then we will have VQ final multiplied by 0,2 on its own. Then we divide both sides by 0,2. So that's what I'm going to do now. (1.6 minus 3 plus 0.8 equals divide by 0.2. And that gives us, and what are we speaking about? Velocity, don't forget the unit, meters per second. Now, what is the meaning of this minus? Remember, let east be positive, that means west is negative. So that is 3 meters per second in magnitude, and the direction is west. Now we are asked to calculate the magnitude of the impulse on ball P during the collision. Impulse means force multiplied by period of time. We know that Q pushed, exerted, a force on P for a period of time, the duration of the collision. That impulse which Q exerted on P is what caused P to undergo a change in velocity and therefore a change in momentum. In fact, the impulse that P experienced equals P's change in momentum. So if we calculate how much P's momentum changed during the collision, then we know the impulse that it experienced during the collision. So we asked the impulse that P experiences. And we know that impulse is equal to the change in momentum, in this case, of P, which is equal to the change in mass times velocity. Now, the mass doesn't change, so it's the mass multiplied by the change in velocity of P during this collision. So what is that equal to? The mass of P is 0,16 kilograms, and the change in velocity is final velocity of P minus initial velocity of P. What are they? Be careful of signs. So the final velocity of P is negative 5 meters per second, minus the initial velocity is positive 10 meters per second. But that minus is from the equation there. So we can see that minus 5 minus 10 is minus 15. Minus 15 meters per second is the change in velocity. We can do it in one step, but let me just make it explicit. And so from that we can then calculate, well, what was the change in momentum, which is the same thing as the impulse. 0.16 multiplied by minus 15 is equal to, what are we speaking about? Change in momentum, impulse, what's the unit? Well, it can be Newton seconds, and that is the same thing as kilogram meter per second. What is the meaning of this minus? West. Now let's just quickly see that Newton seconds and kilogram meter per second actually are the same thing. F net is measured in newtons and time in seconds. So this is clearly the unit of impulse, Newton seconds. But now, remember that F net is ma. So impulse is also equal to ma delta t. Mass is measured in kilograms, acceleration in meters per second squared, time in seconds. Do you see that that seconds cancels out one of those seconds, leaving kilogram meter per second, which we can also write like this, kilogram meter second to the minus 1. So you can see from that Newton seconds and kilogram meter per second are the same thing. And we can also say Newton's second law as force is the rate of change of momentum. And we know that impulse is change in momentum. The rate of change of momentum is force. Force is the rate of change of momentum. A quick recap. In this movie, we used this exam question to help us to revise some concepts about momentum and impulse and the law of conservation of linear momentum. 1. The total momentum of a system of objects remains constant in a closed system. In other words, the sum of the momenta of the objects before a collision equals the sum of the momenta of the objects after a collision. 2. When we answer linear momentum collision calculation questions, we indicate direction by positive and negative signs. We must start by defining which direction we are taking to be positive. Then, we must be very careful to apply this consistently throughout our calculation. 3. The change in momentum that a body experiences during a collision equals the impulse the body experienced during that collision. 4. Impulse is force times the period of time for which that force acts. The unit of impulse is Newton seconds, which is the same thing as kilogram meters per second, the unit of momentum. That's because impulse equals change in momentum. In other words, force equals the rate of change of momentum. If you benefited from this movie, please don't forget to press like and to check out my website, www.learnscience.cosi.